Good afternoon, everyone. Today I will introduce our mini ATM project. This project is not about building a complex banking system. Our main goal is to show how different data structures are used in a simple and clear way. First, I will talk about the main class. The main class controls the whole program. When the program starts, it reads all accounts and transaction data from our load field. During the program runtime, all operations are done in memory. After each transaction or undo operation, the program rewrites the field using the updated data. In this way, the system keeps data consistent and easy to manage. The main class focuses on program flow and field handling, not on account logic.
Okay, let me introduce the main part of our ATM project. I divided into two parts. The first part is display all the operations for user to select. And the second part is after user choosing the selection, it can perform different operations based on user selection. In the first step, we first construct a scanner to make sure user can randomly input their selection. And this two line of code is to make sure persistent storage and to make sure to save all accounts and transaction data, and then to read the data and load it into the memory. And this part of code is to display the selection for users to choose from. Finally, this three line of code is to make sure our system can correctly read user input. For example, if a user chooses the withdraw operation, it should press the 3 and also the line break operations. But the next int can only read the character but does not read line break operations, so we should add the input next line to read the line break to make sure clear the new line characters. In the second step, we use switch to classify each case. In the default case, as there are totally 11 selections, so if user inputs number higher than 11 or lower than 0, it is an invalid input. And in the case 0, it performs login with ID it's invoking account class to perform operations accordingly. Inside the account class, we will use hash map to use the user ID to find out the account. So if we successfully find the account, the subsequent operations were based on this account. And if we did not find it will as an invalid input. And in the case 1, 2, 3, it's all invoke account class to perform the specific operations. In the case 4, we should determine the target account and transfer amount. So we should ask users to input the target account and transfer amount. And in the case 5, 6, 7, 8, it's all invoke the account class to perform the specific operations. In the case 9, it's perform the undo operations. The aim of it is to delay the latest transaction. So inside the account class, we will use stack. Because of its last in first served property, it can store the transaction data and pop from the stack. In the case 10, it is to sort it by amount. So it invokes account class to perform these operations.
Now let's look at the transaction class. Each account operation creates a transaction object. A transaction stores a transaction type, the amount, and the time. Transaction Objects are used to record account activity. They don't control the program, they only store the information. Okay. All transactions are stored in an array list in times order. New transactions are added to the end of the list. This makes it easy to display transaction history in the order they happened. The array list is simple and efficient for recording transactions. Sometimes we want to view transactions by amount instead of time. For this, we use binary list tree, which is organized by transaction amount. If multiple transactions have the same amount, they are grouped into an amount bucket. Each amount bucket stores transactions with the same amount. This design avoids duplicate keys and keeps the tree structure clean. The system also supports an undo function. Each new transaction is pushed onto a stack. When undo is used, the most recent transaction is removed first, because a stack follows last in, first out. It is very suitable for undo operations. Undo only works during the current program session.
In our ATM system, transaction and amount buckets are designed to work together, but it's very different responsibilities. Transaction focus on representing what actually happened, where amount buckets are focused on how transaction organized. Transaction is the small data unit in the system. Every deposit, withdrawal, or transfer event becomes a transaction object. It's defined as a snapshot, meaning it captures the full state of an operation at a specific moment in time. At transaction, this program from line 7 to 12, the data fields are defined: type, amount, balance after trans, date, and description. The amount records how much money it involves, and balance after trans stores account became balanced after the operation. This makes each transaction self-contained and independent from future account changes. In the constructor at transaction from line 16 to 23, the timestamp is generated internally. At line 21, new date ensures that the transaction time is recorded automatically and accurately. Transaction does not perform sorting, searching, or undo operations. It only pulls dates such as amount and time for other date scheduled to use.
Finally, I will introduce the account class. Each account object represents one bank account. It stores the account balance and handles operations such as deposit, withdrawal, and transfer. All accounts are stored in a hash map. The account ID used as the key, and the account object is the value. This allows the system to find the accounts quickly, especially during the loading and transfers.
And I will continue to introduce the account class. First, I will introduce the data field of the account class. And the data field of the account class can be divided into these three types. First, we will have user ID, the date that the account instance created, and the balance of the account. Then we will have the related data structure related to the transactions, which is account array list and account map, which will link the user ID and account instance, and an array list to store user IDs. So I will continue to introduce the account class. First, I will divide it into several parts. The first part is the introducing the data fields. And the data fields can be divided into the basic information of the account, which is the user ID, the dates that the account created, and the balance of the account. Then is the transactions related data fields, which is two array lists, one array list, one stack, and one tree set to store the transactions. And finally, is some static hash map and array list to store the account instance and its user ID. For the second part, we have several display methods which can display the account information and display the account balance and show all the transactions records by time or show all transactions records by amount. Next, for the third part, we have transactions related method, which we have deposit and withdrawal, and finally fund transfer. And in addition, we have undo method to undo the latest transactions, but you can't undo the fund transfer. And we also have, and for the fourth part, we have a search method, which we use a red black tree to store the transactions by amount. So we can search the transactions records by amount, and its time complexity is log O(n). And the key value of that red dot tree is an array list, which is we have mentioned before is amount bucket instance, which is exactly an array list. So for the red black tree, we can use only one comparator and store all the transactions in that red black tree, even if we have multiple transactions that have the same amount. And for the last part, we have some basic method to be invoked in the previous method, which is find account method, which we have found account method, and we use the hash map to find the account instance. We just input the user ID and we will return the account instance. And we have create new account, which also invoke the find account method, and you will check if the user ID have already existed. And we have some database update method to update the database. And we also have the file have save and load method, which will save our data to a file in our computer. And that's all. Thank you.